Good morning, everybody. This is a live extreme weather briefing as we have a moderate risk that has been issued across portions of the northern plains that is focused across eastern South Dakota into southeastern North Dakota. That is mainly for wind, big time straight line winds. It does appear that there's going to be a major windbag event that is going to develop. Also, the tornado threat appears to be maximized. That's going to be across the warm frontal zone that right now is forecast to lift up to near the border, near the North Dakota, South Dakota border. So right now, that is where I'm going to be targeting. I do believe that it could be up near the Aberdeen area. Certainly could be happening as well. So I am looking at, there we go. We got some new overlays on here, the new Team Dominator overlays for my live weather briefings. You can see I got a little pencil out here as well. So right now with this pattern, we basically have an upper level low that is spinning across the southeastern U.S. That's in a counterclockwise fashion. The northerlies on the western side of that upper level low are eventually going to help to clear out the Gulf of Mexico. A little bit of dry air is going to be invading the Gulf of Mexico, and that could give us a much needed break over the next 7 to 10 days. But it's also helping to cause this trough to eject off to the northeast, and it's gained a negatively tilted trough axis as well as it lifts off to the northeast toward the northern plains. This is going to excite rapid cyclogenesis. A surface low is going to lift up through eastern South Dakota, eventually heading up into the northeastern portion of South Dakota, and that's going to bring a warm frontal zone up into near the South Dakota-North Dakota border, and that warm frontal zone looks like it could surge into southeastern North Dakota, eventually into the western portion of Minnesota as well, and there is going to be a very sharp warm frontal zone up into that area, and that warm frontal zone is definitely going to be where I do expect tornadoes to happen and to be maximized. That's the moderate risk. You can see I want to show you the looped HRRR. And right now, the HRRR loop is showing definitely a predominant windbag event that's going to develop. You can see this massive bow echo, almost a derecho type feature that develops into central Nebraska, into south central South Dakota. That lifts through the eastern South Dakota portion, but right to the north of that bulge, north of the massive bulge, that's where that's going to be interacting with the warm frontal zone. And I do think that there is a chance of some supercell storms that could initiate near the warm frontal zone. I'm just starting to get used to this new overlay. Everybody say thank you to Brian O'Toole for putting this together. He's helping me refine some of my production quality a bit. So there you can see this massive bow echo that surges out into central Minnesota. And I'm going to be targeting just on the northern edge of that bulge. The warm frontal zone should lift up to near the North Dakota-South Dakota border. It'll probably nose up into the southeastern portion of the state. Just to the north of that elbow, that's where we're going to be targeting. And I do think that there is going to be a belt of supercell storms that should lift north-northeast and interact with this warm frontal zone. And that's going to be where the greatest tornado potential is going to reside. That's where you have the low-level easterly winds. Anywhere south of that warm front, you're going to have a monster squall line with very widespread damaging wind potential off to the south. That includes eastern Nebraska, eastern South Dakota, late afternoon through the evening hours, fast-moving squall line, massive bow echo. Anywhere to the north side of the bulge, that's where you have the cyclonic vorticity generation side of that bow echo, and that's where you're going to have the greatest threat of a tornado or two, and possibly even a strong tornado as well. Here is the low-level jet pop that we see right at the nose. This is a massive 850 low that develops. Not surprising that we get major cyclogenesis at the low levels. This would be a big-time blizzard for the Black Hills if this were happening earlier in the seasonal cycle. Probably going to get some snow on the backside of that system anyway. But I am watching that low-level jet surge, 50 to 60 knots, right there. That's on the north side of the elbow of the bow echo. That's where the greatest coincidence of surface-based instability and low-level wind shear is going to be located. That low-level jet helps to nose the warm front just into the southeastern corner of North Dakota, and then the supercell storms are going to pass off to the east into central Minnesota. But it's the warm frontal zone that I am most interested in, and it's certainly going to be reinforced as well by precipitation. There is a complex of storms that is happening right now as well, definitely with some precipitation out there. And I want to show you the NAM loop because it definitely shows the warm frontal zone, very well-defined warm frontal zone as it lifts off to the north using the parameter space, surface space instability. There you can see the warm frontal zone setting up, oozing off to the north as well. As that low-level jet surges into the south side of the warm frontal zone, it noses it up into the southeastern portion of North Dakota. That's why the 10% area for tornadoes includes Fargo, the I-29 corridor. I expect that those supercell storms are probably going to initiate to the south of the warm frontal zone in central South Dakota, and then those storms move off to the north-northeast. And once they hit that belt of easterlies within the warm frontal zone, that's when the tornado threat is going to be maximized. And the Bowdle, South Dakota event back in 2010, May 22, some similarities that I see with that event, as well as the supercells on that day evolved across the warm frontal zone. Definitely was a very substantial severe weather event. Let me make sure this live stream is even working as well first. Does look like it is working so far. We do have the new overlays as well. Moderate risk that has been in place for this warm frontal zone. As the surface low migrates up, the warm frontal zone is going to lift up into the southeastern corner of North Dakota, northeastern South Dakota, and any storms that are going to evolve within the warm frontal zone, that's where the greatest low-level shear is located. That's where the greatest instability is also co-located within this zone. We also want to take a look at the surface map too, show you exactly where this ejects. So I'm going to show you now really quickly where the surface low evolves. This is just a NAM model here. We're looking at 12Z. We're going to go at 3-hour increments. And I want to show you this surface low as it evolves. There it is in western Nebraska, late morning hours. We go to the midday hours, starting to deepen, beginning to eject, located over Cherry County during midday. That surface low continuing to lift off to the northeast. Just so I could test out the annotation, there it is, a 999 low, according to the NAM at this time, as it's lifting off to the northeast. Let's go back to the NAM, 3 hours out, 4 p.m. Boom. Rapid deepening, rapid ejection of the surface low. It's located near Pier by about 4 p.m. Warm frontal zone north of I-90 by this time. You can see the easterly surface winds, southeasterly surface winds on the northeastern quadrant of the surface low. Warm frontal zone lifting up into the northeastern portion of South Dakota. I do expect those supercell storms to initiate at around 4 p.m. into central South Dakota. Then they lift off to the northeast and interact with the warm frontal zone, probably producing tornadoes. Look at the moisture pooling, wrapping around the warm frontal zone as well. So I do think that we're going to have to head pretty far west onto the western edge of the moisture. Here's Aberdeen. Aberdeen could be a good target. Storms will initiate off to the southwest, move into the warm frontal zone. And then we step forward to 0Z, and it doesn't, you can see that the warm front noses up through the Red River Valley into the southeastern corner of North Dakota, western Minnesota, a pretty sharp warm frontal zone. North of that area, dew points drop into the upper 50s. Dew points to the south, along into the south of the warm frontal zone, rocket up into the low 70s. There's the warm frontal zone. Surface low back across this area. This is likely where storms are going to fire, and then they're going to lift northeast into that favorable environment, which will start producing tornadoes, basically an environment supportive of a tornado factory up there across northeastern South Dakota into southeastern North Dakota. There's the warm frontal zone stretching across central Minnesota. I've also made some comparisons to the 2010 event, June 17, 2010, the Wadena tornado. Those storms ended up initiating fairly far off to the east as well along the warm front. Looking at the 3-kilometer NAM positioning of the warm front as well. Look at that mixing down to the south. This is at 0Z, so we'll go back to 21Z and we should get a cleaner look of where the warm front is going to set up. Looks to be to the south of Aberdeen, and there is a morning complex of storms that's moving across northwestern Minnesota, moving out of North Dakota. That's going to help to reinforce the warm frontal zone. Look at the dew points into the 70s right along that belt. We're going to have to decide, do we hang out here in Minnesota way out ahead of the main convective line right along out east along the warm front, or do we head out near the initiating boundary and the surface low that's going to be ejecting into central South Dakota? I'm definitely leaning toward heading out toward this area, southwest of Aberdeen, right along the warm frontal zone. Probably will head up to Watertown, head into the central portion of South Dakota, but that's the 3-kilometer NAM positioning of the warm front. There's Aberdeen right there, just at the warm frontal zone at 21Z. And then this entire boundary unzips, and you get a bow echo that's going to be moving off to the east across southeastern, eastern South Dakota. Major widespread wind event. It's going to keep pushing off to the east. That's going to be a long-lived squall line that's going to be associated with widespread damaging wind. But to the north of that elbow, north of the bow echo, any supercell storms that are able to form off the northern edge of the bulge will interact with the warm frontal zone, the greatest low-level wind shear, greatest surface-based instability, and that's going to be pushing into the warm frontal zone. Obviously, it's pretty well defined on the 3-kilometer NAM. Let's go over to the hodograph so I can show you how those hodographs are looking right along the warm frontal zone and show you why that's where we're going to be targeting. Anywhere to the south of the warm frontal zone, it's going to be all about a mega shelf cloud. Anywhere along this narrow ribbon, though, you do have fairly strongly curved hodographs. Any storm that's able to move into that environment along the warm front is going to have the potential of producing tornadoes, potentially significant tornadoes. Let's take a look at a hodograph right near that belt, just to the south of Aberdeen, northeastern South Dakota. The hodographs at 21Z are just a little bit skinny, but well shaped. Here is the hodograph shape. There's the storm motion off to the northeast, due southwest to northeast at about 30 knots. At 0Z, the low-level jet is going to increase. So wherever you can get the low-level jet to increase, you're going to take this favorable hodograph shape. You're going to increase the low-level jet, the 1 kilometer wind, up a little bit further, and that's going to take that favorable hodograph shape and increase the area that's enclosed by the hodograph and the storm motion vector. That area there is proportional to 0 to 1 kilometer storm relative helicity in the low level, 0 to 3 kilometer, depending on whatever level you want to observe. And you also want to see just how well ventilated are these storms. And with that negatively tilted trough, you have very strong mid and upper level winds, a lot of storm relative outflow that's going to be removing hydrometeors and hail from the updrafts. You also have a lot of these low-level easterlies as well, right near the warm front. Just a classic northern plains, high cape, high low-level wind shear type of an environment. But it does bulge out. You get a massive squall line with a bow echo that develops across eastern South Dakota that's going to be pushing through this area. That's definitely a forecast failure scenario, kind of pinching off that zone across the warm front. But look at this big-time cape, very thick cape, near 6,000 cape, loaded gun type of a sounding. You have a cap just above the ground that will need to be breached as the convective temperatures are reached. Convective temperature about 87 degrees, easily going to reach that convective temperature, and then those storms will move off to the northeast at 30 knots. And once they interact with the warm frontal zone, and when the low-level jet increases as we get a little closer to 0Z, if we still have some supercell storms across this environment, then those are going to be producing likely tornadoes. Let's take a look at the low-level jet, 1 kilometer wind, 850s. There it is. There's the warm frontal zone, 35 knots. This is going to be a bulging bow echo of major straight line winds that's going to be pushing through eastern South Dakota. You got to wonder if the instability is going to be pinched off a little bit near the warm frontal zone. But any supercells that are able to develop near the nose of this low-level jet and will move north-northeast toward the warm frontal zone will have the potential of producing even a strong tornado or two. But it does look like this bulging out line is going to try to pinch off that favorable environment for tornadoes. That's why the Storm Prediction Center has slightly lower tornado probabilities. Even though you do have a 10% tornado threat, 3 kilometer NAM bulges this mega bow echo through eastern South Dakota. This is the zone right here that might have potential of producing tornadoes. The only chance of having supercell storms that'll be able to evolve with the warm frontal zone, easterly winds in there. But if the bow echo surges off to the east, it very easily could pinch off that warm sector. That's exactly what the models are indicating. That would reduce the tornado threat. It does appear that the 3 kilometer NAM has some supercell storms that might evolve through eastern South Dakota, and then the squall line pushes off to the east and pinches off its access to clean inflow. And the short-range convective allowing models seem to agree with this scenario. Here's the HRRR scenario, bulging out the bow echo all the way to the I-29 corridor. It does have some supercellular structures across northeastern South Dakota. And this is going to be the target to the north of the bulge. There's your bulging out bow echo. Does it pinch off this corridor along the warm front? If the bow echo is able to surge off to the east, then it could pinch off this area. We call that the pinch. And there's easterly winds up into this belt. If the bow echo is not as prominent, or if it hangs back just a little bit, then you're going to have these supercell storms evolving during a longer time period. But I do think that they develop at about 4 p.m. Central South Dakota, lift off to the northeast. Probably will produce some tornadoes along the warm frontal zone as they lift off to the northeast. And then at about 7 p.m., the bow echo is going to push off to the east, pinch off that warm frontal corridor across northeastern South Dakota. Oops. We're back to the NAM. And we're back. So let's take this just a little bit earlier, back to 21Z. Here you can see the bow echo, derecho. There is probably going to be some embedded supercell storms in there. Temperature dew point spreads are going to be immense with that line. You can see the surface dew point field, according to the HRRR, really only has this warm frontal zone being the only area thermodynamically in terms of moisture as well that can produce tornadoes. Down here further south, you get huge temperature dew point spreads, central Nebraska, and that line is going to come together rapidly down there. And it all depends how quickly that line comes together and how quickly that bow echo is able to bulge out. And that's going to impact the tornado potential. That's at 21Z, 4 p.m., 5 p.m. It does look like maybe on the northern edge of this across east central South Dakota, east of Pierre, east of the Missouri River. That's where you could get the development of some supercell storms. But look at this line already starting to bulge out near the Nebraska-South Dakota border. That's at 5 p.m. This is at 6 p.m. This is when you probably will get a window of tornadoes here between about 4 and 6 p.m. right on the northern edge of this bow. But look at how quickly the bow bulges out. The bow echoes out bulging almost all the way to the I-29 corridor. But it is these supercell storms on the northern edge of the bow. If they've got a little window, if this bow echo here is a little bit slower pushing off to the east, then maybe this environment will be slower to pinch off and you'll be able to get those easterlies streaming into some of these dominant supercell storms. Kind of like a Brady, Nebraska type of an event where these storms are moving due northerly, interacting with the warm frontal zone. Here's the elbow, the knee of the larger scale, mesoscale bow echo. Anywhere to the north of that, you're going to have the potential of embedded tornado vortices as well. So even if you don't get the evolution of supercell storms near the warm frontal zone, then I do think that you're going to have QLCS type tornadoes anywhere north of the elbow. But really, I'm watching this zone for supercell storms to lift off to the north-northeast and evolve across the warm frontal zone. That's at 6 p.m. This is at 7 p.m. You even get the hint at some supercell storms that are going to be getting absorbed into the northern edge of the bow echo. Here's the elbow pushing off to the east of I-29, blasting through the Sioux Falls area at about 6 p.m. I-90 corridor getting impacted by that bulging bow echo. Here's the I-90 corridor. So Sioux Falls, you're probably going to have a widespread wind event. That's why the moderate risk is in place across this zone. But there is the 10% tornado probability anywhere to the north of the elbow. Not a hatch area just because there are some concerns over storm mode. How supercellular and discrete are these supercells going to be across the warm frontal zone? But a lot of times these warm front events come together at the last second. They're conditional. Bowdle was similar to that. I mean, the Vortex project sat out the Bowdle day back in 2010 because the convective allowing models didn't look that favorable up there. And then boom, the tornado of the century happened across northeastern South Dakota along one of these warm frontal zones where you get a belt of low-level easterlies, a surging low-level jet. There's the 995 surface low, bulging bow echo to the south of it. You still have the belt of easterlies. Let's look at 5 p.m. and see just how pinched that is. 995 low, and there does appear to be a window up here with these southeasterly winds. There's the edge of the stable air as you shift over to these easterly winds. And it does look like this zone northeast of Pier, east of the Missouri River. That's where the storms are going to develop about 4 to 5 p.m. Surface low lifts off to the northeast. South central South Dakota lifts off to the northeast. This is where we're going to be targeting southeasterly surface winds just to the northeast of that surface low within this belt of southeasterly winds. That's where we're going to be targeting. Supercell storm should initiate. Bow Echo is going to bulge off to the east, reaching the I-29 corridor by about 6 p.m., bringing with it widespread damaging winds. And any of the supercell storms that are able to lift north-northeast and interact with this warm frontal zone, that's where the tornadoes are going to happen. So thank you, everybody, for joining this weather report. The moderate risk is in place. There is a complex of storms that evolved overnight, certainly. The moderate risk is in place for wind, a big-time wind event, but there is a threat of tornadoes as well, maximized across northeastern South Dakota, southeastern North Dakota, depending on how fast that warm frontal zone lifts up. 12Z model guidance kind of hangs that warm frontal zone into northeastern South Dakota, but eventually those supercell storms are going to slide into southeastern North Dakota right as the low-level jet surges. So thank you, everybody, for tuning in. I'm going to be activating live storm chase mode, of course. We've got Mike Lashendro with us on board today, and we're going to be heading up and chasing this Northern Plains event. The threat of severe weather pushes east tomorrow. Portions of Illinois, even Iowa, eastern Missouri could be that threat. It looks like a slight risk, but I do think that there's going to be a tornado threat as well during the day tomorrow. But right now we are just in the mode of taking one step at a time. Hope you guys enjoy the new Team Dominator overlays here. I know we're a little bit slow to adapt sometimes, but we are coming in hot here with Team Dominator overlays. We got a ticker, we got a lower third. We are dominating once again. So thank you, everybody, for joining me for this weather report. Be sure to tune in, hit those notification bells, and be sure to tune in later on today. Full-blown storm chase mode is going to be activated. Thank you, everybody, for joining us. Never stop chasing.